Dear students, in this video we are going to discuss about chemical periodicity. The term periodicity was first proposed by Mendeleev. According to him, when elements are organized in order of increasing atomic mass and grouped by similarities of chemical properties, a certain pattern or periodicity of properties becomes evident. So Mendeleev arranged elements in the order of increasing atomic masses and grouped elements whose properties are similar. But later on, it was found that the chemical periodicity depends on the position of the elements in the periodic table. Therefore, chemical periodicity can be defined as the occurrence of similar properties in elements occupying similar positions in the periodic table. This is the long form of the periodic table of the elements. So this periodic table consists of 18 groups. When you move from top to bottom, that is, if you go vertical, then it is a group. When you move from left to right, that is, when you move horizontal, then it is a period. As you can see, group 1 is nothing but alkali metals, which comprises of lithium, sodium, potassium, rubidium, cesium and francium. These elements are placed under same group because they have similar electronic configurations. As we can see, lithium is 2s1, sodium is 3s1, potassium is 4s1 and so on. Therefore, we can tell that the general electronic configuration of alkali metals is ns1. Moreover, the one electron which is present in the s orbital is the valence electron, that is the electron which is present in the outermost orbital. Similarly, when you look at the group 2, which can be otherwise called as alkaline earth metals, it comprises of elements beryllium, magnesium, calcium, strontium, barium and radium, whose electronic configuration ends with S2, that is the general electronic configuration of alkaline earth metals is Ns2, where N is the principal quantum number. It can be 2, 3, 4, 5, etc. That means that the valence shell contains 2 electrons in the s orbital for these elements. Similarly, when we look at the noble gases, they have a completely filled electronic configuration, that is nothing but the octet configuration. These elements are noble because their valence shell is completely filled. The 17th group, that is the group 17, is otherwise called as halogen group, which comprises of the elements fluorine, chlorine, bromine, iodine and astatine. The electronic configurations of these elements is S2P5, that is the general electronic configuration is Ns2Np5. Similarly, we have group 6, whose electronic configuration ends up with Ns2Np4. So the electron's role in chemical behavior is very important. Atoms are stable when their outermost s and p subshells are filled. That is known as octet rule or the rule of 8. Electrons in the outermost shell determine the chemical reactivity. That means if you have one more electron than the noble gas electronic configuration, then the element will try to lose the electron, whereas if you have only one electron short of octet configuration, then the element will try to accept electron. So this gives rise to the periodicity of the elements in the periodic table. So based on the electronic configuration only, the elements have been arranged in the periodic table. So when you move from top to bottom, the number of shells will increase. That means hydrogen, for example, will have only one shell, the first shell, in which it will have only one electron in s orbital. That is, the electronic configuration of hydrogen is 1s1. But when you move from hydrogen to lithium, the lithium will have two shells. Therefore, the electronic configuration of lithium will be 1s2, 2s1. Similarly, when you move from left to right, there will be increase in the energy sublevel. That is, from S1 to S2, you will move to Px1 to Py1. So periodicity, the first periodic property is the atomic radii, which is nothing but the distance between the nucleus and valence electron is known as atomic radius. So when we look at the periodic table, the atomic radius increases when we move from top to bottom. When we move from left to right, the atomic radius decreases. This is because when we move from top to bottom, there is an increase in the number of shells, therefore the atomic radius increases. But when we move from left to right, the protonic charge in the nucleus increases, therefore the attraction between the nucleus and valence electron increases, and atomic radius decreases. So this is the summary of periodicity and atomic radius. In a group, that is from top to bottom, atomic radius increases as you move down the column. Across the period, the atomic radius decreases as you move from left to right. So when in a group, adding outermost electron shell, and in a row, when you increase the pulling with the increasing nuclear charge, that is the protonic charge, the atomic radius decreases. So what is ionic radius? Ionic radius, it is also similar, but when you take a neutral atom, then it is atomic radius. When you take an ion, it is ionic radius. Say for example, you have sodium, which is a neutral atom, and you have sodium plus, that is an ion. So in an ion, the ionic radius is nothing but the distance between the nucleus and outermost electron. Similarly, you have chlorine, which is neutral. Then if you determine the radius, it is atomic radius. And the same way you have chloride, which is charged minus anion. Then if you determine the radius, then it is ionic radius. For ionic radius, the periodic pattern is also similar with a slight change. In a group, the ionic radius increases as you move down the column, and across a period, ionic radius is maximum in group 5. So this graph suggests the patterns of ionic radius and compares the radius of neutral atoms and charged ions. From this graph, it is very clear that for neutral atoms, the atomic radius will be higher, and for cations the ionic radius will be lesser, because when when an atom becomes positive, the electron cloud shrinks, therefore the ionic radius decreases. But this is opposite for anions, because from neutral atom, when an atom acquires an electron, accepts an electron and becomes negative, the electron cloud expands, therefore the ionic radius is greater for anions. So cations are smaller compared to neutral atoms, and anions are bigger compared to neutral atoms. The next periodic property is ionization energy. So what is ionization energy? It is the energy needed to remove an electron from a gaseous atom or ion. So when the first electron from a neutral atom is removed, then it is called as first ionization energy. The energy required to remove first electron is known as first ionization energy. The energy required to remove the second electron is known as second ionization energy. So from a neutral atom, when electron is removed, energy is liberated, that is known as ionization energy. For example, when a sodium atom loses an electron and becomes sodium positive, it loses energy of 494 kilojoules per mole. So what is the periodic pattern for ionization energy? In a group, when ionization energy decreases as we move down the column, that is when we move from top to bottom, the ionization energy decreases, because the number of shells increases and the distance between the nuclear protonic charge and the valence electron increases, and which leads to the lesser attraction between the nucleus and valence electron, which is making the ionization energy lesser. Across a period, when the ionization energy increases as we move from left to right, because the charge inside the nucleus increases, which causes more attraction between the nucleus and valence electron, making it difficult to remove the valence electron. So this graph suggests the ionization energies. We can see that for alkali metals, the ionization energy is very low, because it contains loosely bound s1 electrons, and for noble gas elements, the ionization energies are very high because they are completely filled, and from a completely filled shell, it is very difficult to remove an electron. The last periodic property we are going to discuss is electronegativity. So what is electronegativity? It is the measure of how tightly electrons are held between atoms. So say for example, chlorine, which is a halogen element, is a highly electronegative element. It can accept an electron and become Cl minus. That electron which is accepted by chlorine is very tightly held with chlorine because of its high electronegativity. So what is the periodicity of electronegativity? In a group, that is from top to bottom, when you move, electronegativity decreases because the size increases. Across a period, electronegativity increases as we move from left to right. So this is the graph which suggests the electronegativity values of elements in the periodic table. As we can see, for a completed shell, that is for noble gas elements, the electronegativity is very less, because it doesn't need electron and it is already full. But for alkali metals, the electronegativity value is very low. Usually metals are always electropositive and they will be less electronegative. But for halogens, that is fluorine, chlorine, bromine, iodine, the electronegativity values are very high, because they are one electron short of octet configuration, and they try to accept one electron, and that accepted electron is held tightly to the halogens. Therefore, their electronegativity values are very high. In Pauling scale, for fluorine, the electronegativity value is 4, and for chlorine, it is 3. For bromine, it is 2.8, and for iodine, it is 2.5. Other electronegative elements are oxygen and nitrogen. For oxygen, the electronegativity value is 3.5, and for nitrogen, it is 3.1. So, this is the summary of the periodic trends. So, when the atomic radii decreases, ionic radii also decreases. From left to right, the atomic radii, ionic radii decrease, and ionization energy and electronegativity increase. And when we move from top to bottom, that is in a group, the atomic radius and ionic radius increase, and ionization and energy and electronegativity decrease. We can conclude that the size of the atom or ion decides the periodic property. When the size increases, electronegativity and ionization energy decreases, and when the size decreases, the ionization energy and electronegativity increases. Okay, so this is all about the periodic properties. With this, we will complete the video. Thank you.